In this lecture we're going to talk about general normal distributions. It turns out that as before, all normal distributions can be translated back to the standard normal distribution, the distribution of z-values. The z is actually not just a distribution, it's a transformation, and the transformation goes as follows. Z is equal to x minus mu divided by sigma. So what z does is to translate any normal distribution, x normally distributed, to a distribution which could have any, like I said, any mean and standard deviation, and translates it back to a normal distribution with a mean of 0 and a standard deviation of 1. So what we're going to do in general is to start with the distribution, normal distribution of x's. For example, let's say that the mean of the distribution is 4 and the standard deviation is 2. Using this formula up here for z, we would translate all of those or any of those values back down to the z distribution, which has a mean of 0 and a standard deviation of 1. Alright, so if we were to go one standard deviation down from 4, alright, one standard deviation is 2 units. 2 units down from 4 brings us down to 2 on the distribution of x's in this example. Alright, and what we've done on the z distribution is go one standard deviation down, and so that would be a z of minus 1. Similarly, if we were going to go 2 standard deviations up from the 4, alright, one standard deviation is 2 units, so 2 standard deviations would be 4 units. 4 plus 4 is 8, and brings us here on the z distribution. That would correspond to plus 2, meaning plus 2 standard deviations away from the mean, or saying it differently, 2 standard deviations above the mean, and that gives to plus 2. A z of minus 1 again would be 1 standard deviation below the mean. Alright, so let's do this sort of properly and with formulas. So let's say that we're interested in finding the probability of getting an x on a normal distribution between 2 and 8, where the mean of that normal distribution is 4 and the standard deviation of that normal distribution is 2. So we would do the diagrams as we just did on the previous page, but let's do them here. Alright, and we would find or draw the z distribution that corresponds to that. Alright, and we're going to go from 2 to 8 in this particular normal distribution, and this time from scratch, using the formulas, we will calculate those z values that I sort of just waved my hands at last time. So I'd use the formula x minus mu on sigma for the first limit of 2. Alright, this limit here. Subtract 4 the mean, divide by the standard deviation of 2. We get an answer of minus 1, so minus 1 corresponds to the 2. And for the other limit, again, x minus mu on sigma. The other limit is 8, mean 4 divided by standard deviation 2, and that'll give us plus 2. Okay, so the probability of getting an x on this normal distribution between 2 and 8 is identical, exactly equal to the probability of getting a z between minus 1 and 2. Alright, so this can be written as probability of z between minus 1 and 2. Alright, and as I've drawn the diagram, And as we've done in the last, or the previous lecture video, it's an area on the Z that straddles the mean, so we're going to find two values from the tables and we're going to add them. Okay? So this is going to be the probability first of getting Z between -1 and 0, and then we're going to add the probability of getting between 0 and +2. Alright, so let's go to our normal distribution tables. Alright, so first to -1 or 1, and we have a Z value, probability of 3413. And then from 0 to 2, right, the probability there, 0.4772. Okay, and the answer to that, by my calculation, is 0.8185. Alright, from now on we're just going to do a few examples, and hopefully you'll get the idea of this quickly. If you've got a fair idea of what's going on yourself, you can pause these videos, this video, do the problem yourself, and then watch my answer. Alright, but from here on out I'm just going to do several of these and see if we can get some practice at this. Alright, so this example, probability x greater than 60, mean of 55, standard deviation of 3. In all these examples you'll see that I've used whole numbers. There's nothing magic about these whole numbers. We could have any nasty looking numbers that we could imagine, but just to make the examples easy, and you can sort of generalize from there. Alright, so with all of these I strongly suggest that you always draw the diagram, and of course drawing the diagram only is useful if you know what you're drawing. Okay, so hopefully you can understand that. So in this case we have a mean of 55 on this x, probability x greater than 60. 60 is the limit greater than 55. Greater than 60 gets us up in that upper tail there. We're going to translate that to the Z distribution and find the limit corresponding to 60, so that we can find that these two, the probability on the Z, which is equal to the probability on the particular x. Okay, so Z transformation, x minus mu on sigma. The x is the limit, 60 minus 55 divided by 3, and that's looks like 1 2/3, or 1.67. We will use 2 decimal places for the Z table, because that's all the Z table will do for us, right? So we'll in a little bit we'll look that up, but first we still have to identify how we're going to get this probability. Alright, remember that the tables give you the value from 0 to a particular value, so we'll find this value from 0 to 1.67 from the table. That whole side of the distribution is a half, so our probability that we're looking for is the probability of Z greater than 1.67, and that's a half minus, alright, half is all of that side above 0, then we're going to subtract out from 0 to 1.67, which we'll find in the table. Alright, so let's go to our table. 1.67, 1.60, 1, 2, 3, 4, 5, 6, 7. Alright, that's 4525. And that looks like 0475. Okay. Let me make that clearer. So since it's on the edge there, 0475.